This is 0, 1, 2, 3. So you are expecting number 4 to be read and to be put at the data register. So I write this one. D1 have to get the value index number 3. Correct? Agree? Now next one. This is already read something from the array. This command is to replace the value to this array. So now your D2 is equivalent to 1C. Okay? You are going to put in this array, which is the same area just now, and this is 1000 index number 3. You are going to replace this number 4 with this value of D2. So look back the memory before you change it. View memory at location 1000 at index number 3. This is still equivalent to 4. I haven't run the program yet. So look over here. I change over here. Look here. Now I run this command. I'm going to change a value inside the memory, which is the array. Now you can see that my index number 3 in the array had been changed from this value for this command. The last command is just to validate what is the last value back to the data register D2, D3. So D3 must get the latest value, which is 1C. Okay, so last round will be 1C. Understand? So this code is basically for you to assess. Assess means sentuh dia. Treat dia lah. Assess is to read or to write the array value that you have. So you are going to use this command to write or to read the array that you have. Let's change the value. Very simple. Now change your index from 3 to 1. You can change it to 1. Then you are expecting which value will be changed. So if I change my index to 1, so from that one, where is the location that will be replaced? Is this one? Is this one? So 6 will be replaced accordingly to this program. If I change the index value to 7, then you have to learn about this one. 0, 1, 2, 3, 4, 5, 6, 7 is out from the array. You are not going to change anything inside your array. You are changing the memory. So this array have index from 0 to 6 only. So if you want to change, you can change from 0 to 6 only. Understand? So this is a list, a one-dimensional array. Is that the problem? Move address is take the address of the array, which is 1000 into A0, and the rest, this is a command for me to read the value of the array, put to D1, this value, D2, replace to this one, and this is only to validate the answers. That's all. Okay, any questions before I move? The next one. So in general, to calculate the address of any element, the address of any element in a byte word or long word, you have to remember this formula. Means that you have to remember this formula. To get the address of any elements, you have to remember this effective address is equivalent to the base plus signs times index. You have to complete this one first before you class it. So let's look at the example from the slide. Example here. The starting address of a word array, starting address is a base address, of a word array is 830C. What is the address of the word whose index value is 5? So the question asks, what is the address for the index value is 5? So go back to the formula just now. Very simple formula. Effective address is equivalent to base times size, plus size times index. So you have to complete this one first. Okay. So what does it mean? Your base is 830C. This is very simple, right? So your size is 0A. So where does it come from? It's 2 times 5. 2 is coming from the size. Look at the formula just now. For word size, the size is equivalent to 2. For byte size, the size is equivalent to 1. And the long word is equivalent to 4. Just now the questions, the array is the word size. Here is the word array. The word array means that you have 2 times 5. 5 is the index here. So you finally know that for this array, the location at the 5 index will be 8316, which is equivalent like this. This is your area for the index number 5, which is the 1, 2, 3, 4, 5, the 6 elements from that one. So memorize the formula. Okay? Wow. This is to just to know that where's the address of the elements, where's the based on the index. Okay. Next, move. Now we are going to talk about two-dimensional array. Two-dimensional array, by right, you can see that it's by matrix. So, for example here, just now we have this one. The name is magic. This is the declarations of the array, which is 3 times 3. So, define constant of byte, define constant of byte, define constant of byte. So, this is the elements. If you can just imagine that this is actually our array. But in the real world of the microprocessor, it does not match like this. It will be a long list of the array. It does not like this, it will be like this. Because it is going to be seen in the memory accordingly to the values. So you cannot see this one in your memory, you have to see like this. But the thing is, you know that this is a component for the row and column 06, which is this one. This is 01, 02. This is 10, this is baked to the matrix last time. Remember that, this is Form 4 class, mathematics. Matrix, where's the location? Maybe your form is different. Last time I learned this one in Form 4. I remember this. Alright? Okay, next one. The formula to get the effective address is different like the first one just now for the one-dimensional. This is, you also may need to remember this formula. So the effective address is equivalent to base address plus size times the whole thing to this one first, and then you can times this one. Again, the size is this one. Row column will be given, and the n columns also should be given in the question. So let's look at the example. The second code from the ULearn. Just now we are assessing a list, which is a one-dimensional array. The second code is for you to assess a two-dimensional array. Now you need to know which one. Alright? Just now very simple, one-dimensional array. Now we are going to play around with the two-dimensional array. So the concept, the purpose of the code is very simple. Still, go to the array, read or access or copy or write to the array accordingly to the locations. Now because of the elements have row and column, so you have to follow like this. So this is the command. So I have the size, I have the n columns, I have the row, I have the columns. So this is where do you put your array. And this is the command over here. Okay, let's try to do one by one. Okay, run your program over there first. Matrix array. Yeah. Origin 4000, where I put all this information. Origin 5000 is where I put my array. And origin 1000 again is the whole code that I have. So you can run that one, look at those that origin first. So run that one. So go to the first origin, is what just now? Is 4000. 4000 change to 4. So that is the first value that we have on origin 4000. 00, 01, 00, 03, 00, 01, 00, 02. Why does it like this? Because it's a defined constant dot word. Word means 00, the number. Word have 4 digits, right? So it means that the first one here is words which will be 0001. The second one, defined constant W3 0003. That is the word size. Okay, next move to the other location, origin 5000. That is the location of your two-dimensional array. But you cannot see as a row and column. It does not match like that. So at 5000, that is your array. It does look like the same array like the list, the first one-dimensional array, right? It looks like that array. But I do not declare it as a one-dimensional array. This is a two-dimensional array. It's still right like this. Just one line. But the declaration stated that that is a two-dimensional array. So each of the components or the elements inside the array will have its own row and column. Okay? Right? So this is your array. Now look at the program again. Okay, now my origin 1000, before we go to the simulation, this is a new code for you, new load effective address. I do not touch it last time. Load effective address is just like to load the address just now, the move address. It's nearly the same. LEA means load effective address. Load effective address. Load effective address matrix. Matrix is your array over here. to A0. Of course, the destination must be address register because it's loading the address. So what do you expect from here? A0 will be what? What's the address for your memory? What the address for your array? Your array is located at 5,000. So means that later you are going to have your A0 contains the effective address of your array, which is 5,000. Move.w, row to D0. Row is equivalent to 1 to Z0. Now you are looking here. Multiply unsigned and columns to D0. D0 is equivalent to 1 just now. So it's very simple. Any numbers that times 1 will be same number, right? So n columns will be 3. 3 times 1, 3 balik. Okay? 3 times 1 now, D0 will be changed to 3. F.w, column D0. Column means 2. 2 plus 3 just now. This is equivalent to 5. 2 plus 3, right? Multiply unsigned size D0. Size is equivalent to 1. Any number that times 1 will be equivalent to the same number again. So this is 5 just now, right? 5 times 1, D0 is equivalent to 5. So now A0, D0, this is 5 to D7. The elements number 5 will be putting over there. This is to play around with. So now look at the value here. Okay, run this one. The first one, define constant W. This is all done. Okay, now you're looking at your memory just now. This is correct. At 1,000, at 5,000, look at 5,000 here. Just now 5,000 is already there in your array. Okay. Now load effective address to A0. A0 now contains 5,000, correct? Okay, now your A0 contains 5,000. Load effective address matrix A0. Now move the W to row to D0. Row is equivalent to 1. D0 now will be changed to 1. Still okay? Next formula, multiply unsigned n columns to D0. So n columns is equivalent to 3. 3 times 1 is equivalent to 3. And you'll be placing back to D0. Now your D0 is going to be changed to a number which is 3. Okay, next row. F.w, columns D0. Columns is equivalent to 2 plus D0 and replace it back to D0. 2 plus 3 is equivalent to 5. Is equivalent to 5. Now, multiply unsigned size D0. D0 is equivalent to 5. Your size is equivalent to 1. 5 times 1 is equivalent to 5 again. There will be no change on D0. Okay, now the last move, the last syntax is to get the value from your two-dimensional array, which is at value number 5, D0 to D7. So from this one, from this matrix, which is the number will be placed at D7 from your array. Number 3, 3 or 5? 0, 1, 2, 3. 3. 3. So the last answer at D7 ialah 3. Now you understand. So the columns here, A0 just now is the address of your array. D0 is 5, right? Even though this is a two-dimensional array, you have to look at the fifth or the range index number 5. This is 0, 1, 2, 3, 4, 5 is this one. So you are taking the value, you are putting at D7. This command, this program is for you to read the array based on the components of the D0 over here. So, if there is the program like this, so you have to know that which elements that will be out from the code. So it's not simply just that. So you have to look at the code. Any problems for the first array, one-dimensional and two-dimensional? Those codes is very simple for you to access, to write, or to copy, or to replace any things in the array. So any questions? If there are no any questions, I think that you understand. Or maybe do not understand. But okay, I have the recording over there. As long as you can understand, you can play back the record. Okay, let's move. So I've covered the array area. Now we are going to the final one for the stack pointer. This is the most confusing part. Most confusing part in the microprocessor history. Alright. Ready to resolve? But before that, this is another example of how to get the effective address. You just need to simply use the formula just now, understand this one, a long word. A 5 times 7 matrix is defined as long information order. The matrix has a base number, then you have the base, you have the size, you have the base, you have the size, you have the row and n columns plus column. Row is actually 3, yeah? Is it 5 times 7? Row 5, columns? 5 is row, 5 is column, sorry. 5 is row. This is what is the address elements of G5? Okay. Okay, this example is quite simple. 5 times 7 then. 5 times 7 is like this. 1, 2, 3, 4, 5. 5, right? 5, 7.
No.
5 times 7 matrix is what?
No, 5, 7.
Oh, 5, 7. 5, like this.
5, 6.
Oh, this matrix is a right? Like this. So this is 7, and then we have 5, right? Betul macam ni. So this is 5 times 7. So go back to the basics of matrix. So 5 times 7 matrix is this one. You are going to get the address of the element 3, 5. 3, 5 is where? Here. That's the location 3, 5. 3, 0.
5.
This is 5, 7. Sorry, 5, 7. So this is 3. Yeah.
Yeah. No. Yeah.
Right? That's the element, right? That's the element, kan? That's the element. Oh, sorry, 3, 5. Sorry. Yeah. Right? The location? That's the location. So on these values, you can get the address for this particular location or any location using this formula. Any location. Okay, so it's actually a bit longer than the one-dimensional matrix. Okay, let's move on to the stack pointer. Okay, now stack pointer. Okay, stack pointer is a new term for you. Majority who learns microprocessor, stack pointer is very new. Okay, stack pointer, again in bahasa Melayu they call it penunjuk tindanan. Pointer is penunjuk. Stack is tindanan. In English, stack means you are stacking. For example, is a verb. Stack is a verb. Plates, pinggan mangkuk tu you letak susun atas, right? When you put all the pinggan mangkuk one by one, means that you are stacking the plate. You are stacking from the first one to the top level. Stack means you tindankan dia. Alright, that's the concept of the stack pointer. Okay, so now, what is stack? So there are two terms. One is the pointer, another one is only stack. So the terms right now is divided into two. One is pointer, one is stack. This is very important, Stack is an area in memory reserved for reading and writing special or temporary data items such as written addresses and register value. So, in a very simple word, stack is an area from your memory location which is used to store two things, either written address or any data from the register. Bermaksud, dalam memori kamu, dalam memori yang besar itu 16 juta tu, satu area di bawahnya, there's one area at the back of it is reserved and they call it stack. Last kali. This area can be used to store two things. Normally store the data register, and another value is to store the written address. Okay? So now, this is your data register. Let's go back to the first one. Your address register, A7 is the stack pointer. And this is your problem counter status register. So, at the end of this class, you learn all this one already. So now, the command. When you want to put something at the stack, you are going to do an operation, they call it push. Push the data to the stack. If you want to take out the data back from the stack, you call it pop. Push and pop. That's the term. Okay? So it's a push, it's a pop. When you are moving to something, you are going to use this one, this command, dash or minus, bracket stack pointer. If you want to push, then if you want to read back, you are going to comma, bracket, stack pointer plus the area. Okay, now look at the command. So for that, so this is a repetition. The address of the last data item, what call it, placed into the stack is pointed to by the stack pointer. Now that is the stack. First is the stack at the area reserved. The things that pointing the area, they call it a stack pointer. Pointer is pointing the stack. Stack is the area. If I want to point that stack, I call the pointer. I point to it.